Hello, everyone. This presentation is about automatic generation of network topology using Zabbix. My English is poor, so please excuse my presentation while I read for my tablet. First, let me introduce myself and my company. My name is Takeshi Tanaka. I'm an engineer of monitoring system design at NTT Com Engineering. I joined the Zabbix business in 2011. NTT Com Engineering is a company that provides technology and operation for telecommunication systems. NTT is Japan's largest telecommunications group. It was established in 1958 to take over the state-run telecommunications business. It is divided into the telecommunications business and ICT infrastructure business and solution business groups. My company is here as integrated ICT business group. This section is provide background of the development of network visualization technology. In order to draw network topology, a mechanism is needed to detect connection between devices. At Zabbix Summit 2018, I presented a technology of acquiring link layer discovery protocol neighbor device through Zabbix SMP monitoring. Zabbix 7.0 supported version is now available at this URL. This page is Japanese only. Please use automatic translation. After our presentation at Zabbix Summit, we received comments from everyone. Some comments that might be possible to automatically drawing network diagrams. We received many comments when we presented the prototype under development at Zabbix 2019. Today, I presented the result of the development to date. There are the two implementations we are presented today. The first 2D network, 2D network topology using the Zabbix map feature. Second, 3D network topology generated by Zabbix in conjunction with the external engine. They appear to be different implementations. However, there are shared points of information to be stored in Zabbix. This section describes how to store the information needed to generate the network topology in Zabbix. To draw a network topology, 4 elements are required. First, network node information. This is information about the hosts in the network topology. This includes information to be added to the host. Link information. Connected information between hosts. This includes information to be added to the link. Drawing engine. The function that actually draws the topology. This is the part of the reads the node and link information and expresses its picture. Last, placement logic. The drawing rule for placing node in the topology. This is the most important element is placement logic. Zabbix guarantees that a host is the only information in the system. One host can be stored on one node. Additional information can be stored in the host inventory, and automatic expression by network discovery can also be used. The host has no change, so past information cannot the reference. Zabbix is limit in where I can store link information. We consider 3 possible locations to store the link information: history data, host inventory, and host tag. We considered which location would be suitable for storing link information. Actually, unfortunately, Zabbix did not find the location that could meet all the requirements. History storage has been given up. Automatic and manual update for implemented separately. This is why we choose to use history date and host tags. This section describes the drawing engine and placement logic. Zabbix map use a 2D drawing engine. Maps can be generated using Zabbix API. We have a mechanism that we developed to generating two network diagram. First, this external view of network devices. Second, this rack mounted diagram of devices. After 2 developments, we were able to create the mechanism for drawing network diagrams, SADs. The structure of the 2D drawing engine backend. The Zabbix map has an ability to display fault information and item values. We have developed a program to read information and generate map diagram using Zabbix API. A 2D placement logic created method. Draw a network topology by specifying host of host group. This. A reference host is defined and child hosts are drawing by reference link information. Such a method can be used a serverless way. Draw all host registration with Zabbix. Draw hosts included in the specific host group. Draw a host that's one hop ahead of a particular host, this type. As a 3D drawing engine, we use a commercial product. That product using 4DBs. 4DBs is a product developed by Entity Comware, a group company. It allows users to draw in 3D space and visualize change in store along the time axis. This sending information stored in Zabbix to 4DBs. We were able to draw network topology and replay history. The structure is of a 3D drawing backend. 3 information paths. establish a base of information to be read the timing difference. Network structure information in captures hourly. The traffic value information as capture every 10 minutes. Fuel information is distributed using Zabbix action as they occur. They enable both real-time drawing and reduced load. Two methods we created for 3D placement logic. The first, this method draws 3D imaging for each host group. Set x-axis and y-axis for host group. Z-axis for hosts. And those generate the network topology. Importance hosts can be placed the upper tier to visualize the importance of the hosts. This. The second method is drawing the host group in multi-layer. Set z-axis for host group. X-axis and y-axis for hosts. And those generate the network topology. Overlapping floor plan image can be used to visualize network structure and location information. Once the mechanism is in place, we will actually use it. During the development phase, we tested on a small network. We need a large-scale network to verify the particularity of the mechanism. We use Interrupt Tokyo. Interrupt Tokyo is an annual exhibition of information and communication technology held in Japan. The 2024 new expected for draw 120,000 visitors. The exhibition will be preceded by the large networking event, ShowNet. ShowNet is a volunteer effort with equipment and personnel. Many manufacturers will provide equipment and interoperability will be verified. Here is a diagram of the network. This diagram is built at this year ShowNet. Percepting companion. Zabbix Japan provides ShowNet for monitoring system. We have integrated the developed functionality into it. ShowNet was built in only 1 week. We brought in the core group of engineers. This equipment has been running since 2019, and this year will be the 5th. The figure of the right, this figure is right in the schematic on the system. This is part of network topology created this year. LLDP information and host tag information is drawn. Blue line is LLDP, green line is manual setting host tags. The system is divided into host group for each application. A network diagram was generated for each host group. Local networks and administrator networks, host groups. This year, 3D network topology created this year. It shows 100 hosts monitored by Zabbix as on network topology. The physical connection of the equipment are visualized in the 3D structure. This one drawing host group in multi-layers. A floor plan image of pavilion is included in the background. The network structure and physical location are displayed in one screen. These network diagrams were designed and implemented in 6 days. We have introduced the mechanism of drawing in 2D and 3D in network topology. Consider the future and difference between 2D and 3D. Which is the best drawing method for network topology, 2D or 3D? Compare the drawings of large networks. This image shows a full view of a 3D network topology with 1,000 host drawing. Even though the number of hosts is large, you can still read the location and connections. It draws some number of hosts in 2D. I was able to draw the network topology, but it would have generated a huge map to show all the hosts in 2D. To display all hosts 2D was generated a gigantic map, this size map. The network structure is difficult to decipher because of the countless overlapping links. This overlapping. Focus on portion of the network to see. With a visible number of hosts, it's easier to grasp the relationship in 2D drawing. 3D drawing, overlapping links, 2D drawing, see. The z-axis is a major difference between 2D and 3D. 3D allows for more information by one axis. It is possible to add information such as the importance of the equipment and its location. As shown in this image, higher hosts, this important. The more important it is, higher the priority can be visually understood. (2D and 3D has strengths and weakness. 2D is suitable for understanding detailed relationship. 3D is suitable for the bird's eye view of our whole pictures. By using both 2D and 3D, we can provide optimal visibility. Finally, it's considered the value of integrated Zabbix on topology. There's an advantage to working with Zabbix and network topology. visibility of relationship between hosts, discovery of patterns that are not when looking at portions of the network, awareness the presence of structure bottleneck, combined with Zabbix expression capabilities. It can generate up-to-date network topologies. We believe that additional network topology functionality to Zabbix will improve the usability of Zabbix. This presentation has described a mechanism of automatically drawing network topologies. This mechanism also serves as a framework for visualizing host-to-host relationship. They are contrast structure in computers that can be represented by topologies. For example, the topology of security structure and application architecture can also be represented by topology. Besides IT, there are many other topologies, such as social networks, logistics networks, and so on. We believe that this technology will help broaden the scope of application of Zabbix. That's it for my presentation. You can see actually contents of what I presentation at the booth outside venue. This contents. Thank you.